All right, so I'm going to start with number 16, y equals negative cosine of 4x. So amplitude is 1. The number in front of the cosine is your a value, which in this case, the a value is negative 1. Our amplitude is the absolute value of that a value, so amplitude is 1. The period is, for the parent function of cosine, period is always 2 pi. That's the default. This one is not because there's a b value. So this 4 is our b value, and a b value is a horizontal stretch or compression. It's opposite what you think it should be. Typically, you know your a values really well. If a is greater than 1, it's a vertical stretch. If a is between 0 and 1, it's a vertical compression. For the b value, horizontal stretch and compression, it's the opposite rules as that. So a b value that's greater than 1, like this problem, would be a horizontal compression. Another thing that you can do is first figure out the period and then decide if it's a horizontal stretch or compression, because it should make sense. Okay, here's what I mean by that. To find period, the formula is 2 pi divided by the absolute value of b. It is possible that b can be negative. We're not doing that in this class. So for us, b value will always be positive. So 2 pi divided by 4 gets you pi over 2. So that means that the length of one cycle is pi over 2. Our normal length of a cycle for the parent function is 2 pi, right? And if you know what those values are, and you can look at the graph to help you see them, you see that pi over 2 is smaller than 2 pi. So what normally happens for our parent cosine function, it normally looks like this. This is the parent cosine function. It starts at 0, it ends at 2 pi. This is the midpoint and the 2 smaller midpoints. These are the 5 critical values of your parent cosine value. Look, that it's from 0 to 2 pi. That's one cycle. But when you have a period of pi over 2, right, that would mean it starts here, but it ends at pi over 2. And then everything would be shoved in between those 2 points, your start point and your end point. So look at the blue 5 critical values compared to the red 5 critical values. We took this function, right, and one cycle normally covers a distance of 2 pi. Now we're saying one cycle covers a distance of pi over 2. So we've horizontally compressed it, right? Imagine taking those outer 2 points on the red and just squeezing it, right, making it smaller. So this is a horizontal compression by a factor of 1/4, right? Because you're making it smaller, you want that by factor part to be 1/4. Okay, now I'm actually going to erase the red because what I have here in blue, I have y equals cosine of 4x. This is the blue, okay? You should know that cosine starts at 1 unless there's an amplitude change, right? So it starts at 1 and then it ends up at 1. Okay, so that's how I got this first point here and then this last point here. This ending point is at this location because from the starting point to the ending point, that distance between those 2 points has to be pi over 2. So from 0 to pi over 2, that's a distance of pi over 2. It was brought up today in the extra help that if your starting point is at 0, like this one, then your ending point will match your period. Okay, one more time. If your starting point is at 0, then your ending point will match the period. Okay, but if your starting point is somewhere else, then your ending point won't match your period. When would the starting point not be at 0? The starting point wouldn't be at 0 if there was a horizontal shift, a phase shift. So if we take that starting point and start it somewhere else because of a phase shift, then you would have to count a distance of pi over 2, which I think we're going to do in another example today in the extra help examples here. Okay, so then back down here at the bottom, you know the start and the end. That midpoint is down at -1, and that's, of course, unless there's an amplitude change, then that would be different. So that's how I got this dot down here. And then your two smaller midpoints are on the x-axis, which is how I got those. So this is one cycle that you see here graphed on the graph paper. Now, we still didn't graph the negative sign yet, okay? So the negative sign is a reflection over the x-axis, okay? And what you can do is you can graph the function without the negative sign if that's confusing to you, and then literally, is it gonna let me do this? Literally switch them. No, it's not, because I did this so many times. So literally switch them. So all that maximum points become minimum points. The maximum point from up there became this minimum point over here. And then I'm going to erase that guy. He goes up. So all the maximums become minimums. All the minimums become maximums. You're reflecting those points over the x-axis, right? They hop over the x-axis. This is one cycle, and then copy and paste. A bunch of people have said they find the hardest thing so far is the copying and pasting part. I suggest finding a pattern. So instead of just trying to do this from left to right, find a pattern with the dots, meaning the dots on the bottom are every other. So I'm going to continue on this line going every other. This maximum point is always on that middle space. So middle space, put a dot up here. Middle space, put a dot up here. Middle space, put a dot up here. And then those are going every other. You find a pattern with those. And then the x-axis ones is always right in between. Okay? And then you would fill that all in and connect the dots. The arrows at the end, you want to focus, I'm just going to start here. The arrows on the end, you want to say what would happen next, right? So what's about to happen? This is about to curve up, right? So I'm very picky about that. I pay attention to that detail. Don't make it go down. That should seem wrong because the minimum point on my graph should be -1. No point should ever go below -1. So don't do that, right? And then on this side, I think the same thing happens. Now, it doesn't always curve up. There is a way that it could possibly continue down. That would happen if, let's just pretend, okay, this is totally pretend. Let's pretend that it hit like that. Right? What would happen next? It wouldn't curve up like that, right? It doesn't curve there. It would keep continuing down. If it hit right here at the very end, if that's how my graph ended, it would continue down to keep going to that minimum point. Okay? So that left part of the graph there is wrong, but I was just making a point. All right, so that's number 16. Number 9. Number 9 is cosine again. So as soon as I see cosine, I'm thinking in my head, up, down, x-axis, x-axis, right? That's the parent function. That's what I'm thinking in my head. Notice I have no numbers in that drawing that I just drew. I just know the basic sequence of the points. Those are my 5 critical points. So the amplitude here is 1 because of the a value that's in front is a 1. Period is 2 pi because there is no b value. The b value, if there were to be one, would be right there. Right? The b value is 1 in this case, so no period change. This x minus pi over 2 is the phase shift. So phase shift is a way of saying horizontal shift. We're going right, pi over 2. So this point right here that I'm highlighting, that's our normal start point. Okay, this is our normal start point, up at 1. So I'm going to put it right here. That's the normal start point. But because we are doing a phase shift pi over 2 to the right, I'm going to take that point, that start point, and move it pi over 2 to the right. And so this is now my start point. So the next thing you usually try to figure out is your ending point. Okay, where do I end? My suggestion, and I think this will help you for next year for pre-calc, is to do this algebraically, right? You're going to take your starting point. Where on the x-axis are you? You're at pi over 2. And you're going to add to it the period length, which is 2 pi. That will then get you your ending point. So when you add these two things together, you need to get a common denominator. So I'm going to change this to 4 pi over 2. okay? And that gets me 5 pi over 2. So 5 pi over 2 is going to be my ending point. What happens there? Cosine, it ends up at its amplitude, which is 1 in this case. I would then try to find this minimum point, which is halfway in between these. So halfway in between is 3 pi over 2 just by looking at the graph paper. That's going to be my minimum point. And then my two smaller midpoints are my x-axis. Those are my 5 critical values. Then I'm going to, again, find a pattern, copy and paste. This one might be easier to start with the x-axis. So the x-axis is happening at pi, 2 pi, 3 pi, 4 pi, right? All the pi's. And then the points in between that are just alternating up and down. So down, up, down, up, down, up, down, up, okay? And then pay attention to the arrows. Here, this is going down to its minimum, so my arrow is going like that. And then here, this is going to keep going up towards that maximum, so it keeps going up. Don't curve it yet. Okay, those 5 pink points are my 5 criticals. All right, next. Number 4. Number 4 is a sine graph. So sine starts at 0, 0. It ends on the x-axis. Its midpoint is the x-axis. The first midpoint goes up to the max. The second midpoint goes down to the minimum, right? Those are your 5 critical points. Amplitude. Amplitude for this problem is 2 because of the a value out in front. The period is going to change because of that 1/2. So again, the formula is 2 pi divided by the b value, which is 1/2. Do a little keep change flip here. So 2 pi times 2, which is 4 pi. So the period here is 4 pi. That's a horizontal stretch. Normally, for sine, I'm going to start and end between 0 and 2 pi. That's one cycle. For this example, we're saying that from start to end, it's going to be from 0 to 4 pi. That's going to be one cycle that has all 5 critical points in it. So we are horizontally stretching this by a factor of 2. I like how I use my hands as if you guys can see what I'm doing. Okay, so my starting point is 0, 0. It doesn't change because there was no vertical shift, there was no phase shift, so that's the same. My ending point is going to match the period because if we start at 0, the period will match with the ending point, right? The distance between your start and your end should be your period distance, right? So from start to end, 4 pi, that matches my period, the period. Okay. Next thing I find is that midpoint right in the middle. That's at 2 pi. This first midpoint between the first and second points at pi, this is going to go up to the amplitude. So up 2 spaces. Counting 2 spaces from the x-axis line. The second midpoint is at 3 pi. This one goes down. It's worth noting here that if there was a negative sign on this for a reflection over the x-axis, right, just pretend for a second, then this point would have been the down point and this point would have been the up point. Okay, so a reflection just changes all your downs to ups and ups to downs. These are your 5 critical points. I'm then going to copy and paste. Now, this is the most common mistake I've seen. I've seen people copy and paste like this. Right? This is not correct. Do you see how it's not a copy and paste? Like if you take those 5 points, copy them and shift them, they will not fall right on top of those pink points, right? It should look wrong, okay? I've seen this answer a few times on your homework. So copy and paste, I would start with the x-axis here. You've got dots at 4 pi, 2 pi, 0. So there would be another one again at 2 pi and 4 pi, right? All those x-axis dots are happening every 2 pi. Then the in-between points alternate. Down, up, right? A lot of people switch those 2 points. Now you can see that if I copy and paste those 5 blue ones, if I slide them over, they would fall right on top of those 5 pink ones, right? And 5 pink ones would include, like that is technically a pink as well. I'm gonna keep it blue because I want it to be a critical. My 5 criticals are in blue there, okay? So then my graph looks like this. Okay, next. This was from the Google form. Which equation is represented by the graph below? So the middle of the graph is the x-axis right here. I noticed that first of all, they all have an amplitude of 2. I hope you guys realize that this graph has an amplitude of 2 because we're going up 2 from the x-axis for our maximum points, down 2 from the x-axis for our minimum point. So hopefully even if these weren't all 2s, you would be able to know that the amplitude was 2. So the question is, which b value is correct? Right? The b value, what does that have influence over? That has influence over the period. Now the b value does not equal the period, right? To find period, you do 2 pi divided by b. I'm going to erase this so it's not confusing. So period is 2 pi divided by b. What's the period of this graph? Right? What's the period of this graph? So look from the start of cosine to the end of cosine. This is the start. This is the end. We know that because cosine starts up at its maximum and it ends up at its maximum. So what distance is that? It's from 0 to 2 pi over 3. So our period is 2 pi over 3. So which of these, when you do 2 pi divided by b, which one gets you 2 pi over 3? So here in example 1, the b value is 3. So if I put that into the formula, do I get the correct period? Yes, I do. So this first one is the answer, okay? Option 2 was sine, so that should be out. This was a cosine graph. Again, I know it's cosine because it starts at its maximum and it ends at its maximum. So that eliminates this option 4 as well. So a lot of people picked number 3. On number 3, the b value is 2 pi over 3. If I put 2 pi over 3 into this formula for period, I don't get the correct period that matches the graph. So I hope that was helpful. If you still have further questions about this, reach out to me in Google Hangout. We can set up a video conference or show up to the Google Meet. Extra helps. All right, guys, have a good day.